Okay, guys, so today's lab is called Junk Wars or Antique Roadshow. Okay, so Mrs. Dowdy and Mr. Curry recently decided that they would open up their own business that they could earn extra money from in the summertime. Since they both like antiques, they decided that they would open up a shop to resell these antiques they purchased at auctions. One of their first purchases was going to be a beautiful oak roll top desk inlaid with decorative copper metal accents. The current owner assured them that the desk was made of solid oak and solid copper. Not wanting to damage the desk, they asked Mr. Leberman, Mr. Chaput, and Mrs. Vastel to help them determine another way to find out if the desk was actually an antique. Because, you don't want to spend all this money and find out that it's not what you think it is, okay? So the problem or the question that we're trying to discover today is the desk an antique or is it a cheap forgery? So we also know, the other question says, will different material types have different densities? We know the answer to that question. We know that different materials do have different densities. Okay? So our hypothesis is if the density of the wood and the copper fall within the normal known values of those materials, then the desk is a legitimate antique. Okay, so that's our hypothesis. We have a couple different materials, so I'm not going to use a ruler today, but normally in this lab you have the option to use a ruler or a digital caliper. So a digital caliper is this device right here. And basically, it's an electronic ruler, okay? So what happens is I adjust it to what I'm trying to measure. And when it's on, if you look, I don't know how well you can see that number, but there are numbers reading out on here, okay? So, and this is in millimeters. We'll just have to make a conversion to centimeters, okay? Which is really simple. Milli means 1,000. Centi means 100, so we just have to move the decimal point one place to the left, okay? So so I'm going to use this. This is a digital caliper, okay? Electronic scale, I have my scale set up front here. A calculator, of course you can use a calculator for your density calculations, or you can just open another tab on your computer screen, okay? And then a density cube set containing 6 unknowns. Here's my cube set, and it contains 6 unknown materials. Okay? I don't like how that's upside down. That's not much better. Okay. I think Zoom updated in my setting that I had to reverse it. I think it's gone now. We don't really need to have the numbers facing the right way, so I wouldn't worry about it. I'll announce the numbers so you guys should know. So here is our procedure. It says measure the height, width, and length of each cube to the nearest tenth of a centimeter. Record this information in Table 1. If you choose to utilize the digital caliper, we're going to record the values to the nearest hundredth. So we'll record our length, width, and height values to the nearest hundredth. Using the scale, obtain the mass of the cube, and then it reminds you to use the same scale throughout the entire investigation. This is more for when you guys are doing this lab, because I'll have 3 scales set up, and to limit error, you use the same scale, because if the scale is off by a little bit, at least all your data is off by a little bit, versus, okay, well, this cube was on this scale and it was off a little, but the cube over there was right. And so you use the same scale, and that is in any investigation, not just this classroom, but any investigation. After we collect the data, you are going to collect the volume of the cube. So remember that volume is length times width times height, and you're going to record this information in Table 1. As a reminder, density is calculated like this. So density is the mass of the object divided by the volume. And then you're going to calculate the density of each cube. Again, you're recording this in Table 1, and you're rounding to the nearest tenth for metals and woods. Okay? So I'm going to scroll down to Table 1, and it looks like this. So you guys will be filling out this table. So this box right here, this measurements box, we'll be filling this in together. Once we fill this in, you're going to be responsible for calculating the volume and then the density of these objects, okay? Now, if we look across my cube numbers, now they don't go in order, so be careful about that. Like, we're starting with cube number 2, okay? So cube 2 is a metal, so is cube 5, and so is cube 7. And then the woods are 3, 6, and 9, okay? So that will come into play. Now, as a reminder, you will need this data set and these calculations for the summative next week. Okay, so you want to make sure you get these done today. Okay, or else you're going to be watching this video that I'm recording to make sure that you get the information, which during the not being prepared for the summative, you don't really want that. Okay, so make sure you're collecting this data, have it in front of you. It is important. Okay. Okay, so that's what we're going to do. The analysis part we'll talk about after we get through the measurements, okay? So I'm going to start with block 2, okay? And now with the digital caliper, you always want to make sure that it's reading 0 at the 0 measurement, okay? So I'm going to, it's the first one, height, okay? So height is 2.48. Width 2.48. And then the length 2.46. And now I'm going to get the mass of block number 2. And again, I'm going to make sure my scale reads 0 before I put the block on. And I get 124.77. So 124.8. So that is block 2. So now we are going to move on to block number 3, which block number 3 is a wood. Again, I want to make sure my digital caliper reads 0 on 0. Okay. And height 2.38. Width 2.28. And the length 2.45. Now I'm going to go find the mass. Which is 10.5. Block number 5. Okay. Oh, heights first. 2.48. 2.44. 2.45. And now my mass. 134.3. Block number 6. Height first. 2.50. 2.50. 2.49. 19.9 is the mass. Block 6. Block number 7. 2.48. 2.45. 2.46. 145.7. Okay, Okay, and then last but not least, my block number 9. Okay, so block number 9 is it. This is our last one. So 2.44. 2.32, 2.41, 7.7. Okay, so I know you now have all your measurements, but I do not want, I'm going to give you the rest of class to finish this, but let me get through the directions for how to do the calculations, how to do the analysis, okay? So you'll have plenty of time, okay, to get what you need to get done today, okay? So the first thing you will do is calculate the volume, okay? And again, in the procedure, it tells you how to calculate the volume. It's length times width times height. Then density you have to calculate, and it's going to be the mass divided by the volume, okay? Then it asks you to identify the independent and dependent variables of this investigation. So we're going to do that together right now, okay? So remember, the independent variable is the variable that I changed. What did I change up here? The size, not the size of the blocks, but okay, so the size and mass did change, but why did they change? The different types of blocks. So the independent variable is the identity of the block, okay? Because that's what I changed, okay? I changed what identity we were measuring, okay? Now the dependent variable is the data we collect, okay? So we collected height, width, length, and mass. Am I going to put all of those for my dependent variable, or is there one calculation that kind of covers them all? Yeah, so density is going to be our dependent variable because that's the one calculation that kind of has all our data in it. And that's what we're going to use to identify, okay? So those are your two variables. Now, again, once you finish your volume, once you finish your density, you can then create your graph. Your graph is the second assignment on Unified Classroom, okay? It's just a blank Google Sheet. What I don't want you to do is copy and paste this data table into that Google Sheet. If that was the case, I would have just linked it, okay? You need to create your own columns, okay? Because remember, when we graph, you only have two columns in there, your independent variable and your dependent variable, okay? So your graphing guidelines, I linked it here at the bottom of this page, but remember, this is your rubric for a graph, okay? And I'm actually going to be grading this graph, okay? And so you need to submit it by Monday, because Monday is a Wildcat Day, guys. So I will see you Monday. Okay, we have no school Tuesday, so Monday's a Wildcat Day. Okay, so your first point is proper graph type choice. So down here it tells you, okay, you use a line graph when the data is continuous. Use a bar graph when the x values do not have logical intermittent points. And then a pie graph if it's a percent. 1 point for the proper title, the effect of the independent variable on the dependent variable. But don't use the word independent and dependent variable. You're going to actually put those words in, okay? Axes, so that is 1 point, so that your independent variable is on your x and your dependent variable is on your y. Your data is inputted accurately into the spreadsheet, meaning you have the correct data there, okay? I'm not at this point, if you do a calculation wrong, I'm not going to say your data is inputted correctly, because that's not the part that was incorrect. It was your calculation. I'm looking that you took the data that you found and you inputted it correctly into the spreadsheet. And then 2 points, remember, for your graph is customized. So you can change the color, you can change the font, you can change the data labels, you can add trend lines. There's so much that you can do. So go back and kind of play around with that again. Because like I said, we haven't done graphs in a while. So you may need to kind of remind yourself how to do this. So you have this digital graphing guideline sheet that will help you. And then on Unified Classroom, there is on my lab report handouts tab, there's a how to graph in Google Sheets. if you're having trouble on how to remember to graph, you need to open up that. Because like I said, this is going to be a lab grade, so I can't tell you how to graph, but I can tell you to look at a document that will tell you how to graph. Okay? So that is what I'm looking for you guys to do. So are there any questions in here? No? Okay, guys, so I'm going to pause my video.